Good morning, everyone. My name is Ravi. I'm the co-founder and CEO of Zeeve. And today we are talking about blockchain scalability. So blockchain scalability is one of the most important topic in the blockchain space. And I'll tell you the reasons why it is important as well as difficult at the same time. So we are conducting this webinar series in three parts. In the first of the series today, we are talking about what scalability is, what is the scalability trilemma, why it is difficult to achieve, and what are the different ways where blockchain scalability has been achieved. And in the subsequent webinars, we are going to deep dive into two of the major areas within blockchain scalability. One is rollups, and the second is app chains. So today we are going to take an overview of all different solutions that have been deployed for achieving blockchain scalability. So first, just when we talk about scalability, what we understand by it. In the general computer systems, when scalability talks about, we talk about that, there needs to be a higher throughput, higher processing power. So if we talk about scalable systems, that you are building something which is scalable, what we mean by that, that the system would be able to handle more users, more transactions. And typically in the traditional solutions or systems, we try to add more infrastructure to it. We design the database in a manner that it can be scaled further. So adding more resources suffice when we talk about. So some changes to the design architecture and adding more resources is more than sufficient to achieve scalability. But when we talk about blockchain, the scalability has got a much broader meaning, and it's quite distinct when we talk about a client server or a monolithic kind of architecture. So let's first imagine how a blockchain network operates. What gives blockchain the tenets of decentralization or security or trustless networks? So what provides that? So just imagine there's a blockchain network, and network means it consists of multiple nodes, and multiple nodes are getting synced up with each other. Now, when we talk about security or decentralization, how does it happen in the case of blockchain? Because each and every node, first, there's a ledger which is synced up across all the nodes. And whenever a new data is to be written on a ledger, there needs to be a consensus. So there's a consensus protocol which allows different people, and anyone can become a miner or a validator to participate in the consensus. So it is democratic, it is unbiased, and once a consensus is achieved, then somebody get the right to create a new block, a set of transactions to the ledger. So this is how a ledger is updated. Now, imagining a blockchain network in this way, whenever a new transaction happens, those transactions are combined in a block. The block is validated, verified, and then written by the miner into the ledger. And then that ledger is synced up across all the nodes in the network. Now, if you see, there are multiple moving parts here. So for example, let's say how to increase decentralization. If there would be more number of nodes being hosted by different people unknown to each other, geographically spread out. So if a blockchain has got 1,000 nodes or 500 nodes or 550,000 nodes or even 500,000 nodes, as you increase the number of nodes, you are increasing the amount of decentralization. And at the same time, you are increasing security, because more the number of nodes means there is no single point of failure. Even if somebody wants to take control of the blockchain, the classic 51% attack, it would not be possible as the number of nodes increases. But the problem is that as the number of nodes increases, then how the data syncing will happen across different nodes? Because the ledger needs to be synced up across all the nodes. As the nodes increase, then the time to sync up the data increases. The time to achieve consensus increases. And then that reduces the transaction throughput. And that's how increasing security and decentralization will reduce scalability or put a limit on the scalability. So as Vitalik also mentioned, that if we talk about a smart contract platform like Ethereum, if we try to achieve more security and decentralization, it will put a limit to how much scalable a system can be. And that is what gives rise to Blockchain Trilemma. So, and you can increase scalability by sacrificing, or by, there would be some kind of trade-off, whether in the terms of security or decentralization. Like, for example, there are quite a few new blockchain protocols that launch initially. They put a limit on the number of nodes who can be validators on the network. So they hamper a bit of security. They try to manage it. They call permissioned consensus. They try to control the whole permissioning based on this, but there's a centralization that happens. So they may manage security to a level by making it permission, but then the decentralization hampers, but they are able to achieve higher scalability. So whichever way you see it, if you try to increase one or two, it will definitely hamper, or you need to sacrifice the third component to it. So this is what comes out as a triangle, and you try to increase or improve any side, it will have an impact on the other sides. Now, there are various ways to solve this, because first, why we need to solve this? If blockchain needs to be adopted at the enterprise level, like, when people started talking about whole decentralized finance and how blockchain can revolutionize the financial services space, where the middlemen or intermediaries who are providing very less value can be removed or reduced to bring in more efficiency, to reduce the cost of transaction, and bring in a lot of trust and transparency in the transactions on network. But if blockchain needs to compete with the traditional systems, then of course, the kind of throughput, performance, experience, which is there in the traditional system has to be replicated in the blockchain space. And that's why scalability is required. So if, let's say, we want to achieve, as compared to Ethereum, where you can process just few transactions a second, vis-a-vis Visa, which can process 100,000 transactions per second. So of course, blockchain also needs to achieve that kind of transaction throughput to be at par with the traditional systems and bring in the same kind of experience. The second is, you have seen that, what happened and has been happening in Ethereum from time to time. When CryptoKitties was launched in 2017, suddenly there was a massive surge in the gas price. And the reason is because how the gas price, the phenomena of gas price works in Ethereum and other blockchains is that it's based on auction. Because we know that every 3 seconds, a new block will be written, and a new block has got a certain limit on the size of the block. So that means it can take only a certain number of transactions. So that means only a certain number of transactions can be committed to blockchain every 3 seconds or 4 seconds, whatever is the block time. And what happens that if there are more transactions that need to be committed, so whenever there's a surge in the number of transactions that people want, like what happened in the case of CryptoKitties, or when it happened during the DeFi summer, when more and more transactions started happening, then these transactions start competing with each other. So there is a price bid, and the bid continues to increase. And that's how the price of gas fee increase. I remember 2 years back when we were trying to deploy a smart contract, which hardly cost $1 or $2, was costing almost like $1,600 to just deploy a smart contract. The gas fee became so high. So that was a time when there was an NFT craze happened, and DeFi was booming. A lot of TVL was being locked, etc. So, but what happens if the gas fee becomes so high, then the cost of transaction becomes so high, then of course people will start losing interest. You would not be able to do financial transactions. If you're doing sending somebody USDT worth $100 or any other token worth $100, and if the gas price itself is $10, $20, $30, it does not make any sense. So that is the reason the scalability issue needs to be resolved. But at the same time, since we are talking about blockchain tech, which is based on security and decentralization, we need to find solutions where we can increase the throughput, we can improve the scalability without hampering the security and decentralization. So that is where, all these solutions have been designed over a period of time, and continuous improvements are being done. Newer solutions are coming in to solve the scalability challenges, yet at the same time retaining security and decentralization. So now, if you see, we have divided this into 3 parts. So one is on-chain solutions at the layer 1 itself. So now what is layer 1? So all the blockchains that we see, Bitcoin, Ethereum, they are all called layer 1 solutions. They are the main chain. So parent chains or main chains or layer 1, these are all refer to the same thing. So what can be done on the layer 1 itself? Some ways, some technological improvements, or some methods by which we can improve the scalability without hampering the decentralization and security. The second are how we can take the whole transaction processing outside the layer 1 and can do it somewhere else, and then submit that proof on the layer on the main chain or layer 1. And third is app chains, which again has got a behaves very similar to layer 2 solution. They are like layer 2 solution, but they have got a very specific purpose, and they are getting a lot of traction in last 1 year or so. So first, let's start with what are the different solutions that have been done on the layer 1 itself, on the on-chain. So here, they are called on-chain because we are trying to improve the transactions within the layer 1 itself. We are not moving outside the chain. So there are 2-3 solutions. One is hard forking. The second is Segwit, and third is Sharding. So we'll talk about these 3 in bit details. So as I mentioned, a block is written every certain period of time. Like in the case of Ethereum, a new block is being written every 3 seconds. Now this block has got a certain size. So there's a time when each block is written, or each block is finalized before the next block can be written, and each block has got a certain size. So we can increase the size of the block, or we can reduce the time from 3 seconds to 1 second, or even less than 1 second. So these are some ways through which the transaction throughput can be increased. So hard forking was typically done. We do have some hard forks. Now, there are some planned hard forks, maybe due to any reason. Maybe some invalid data has come into a block. That's why there may be a planned hard fork, or any other reason. But then there are some contentious hard fork also. So what is hard fork? Hard fork is a chain is running, and a new chain comes out of it, and people start adopting the new chain. So what happens in a blockchain is that when a new block is written, at that time, multiple new blocks can be written. Because you imagine there is a huge network of thousands and thousands of nodes spread across different geographies. Now, it may be possible that, somebody has written a block, and but in another geography, it may be lagging. So the blocks are not completely synced up with each other. There's a time difference that happens due to geographical distribution of the nodes. So in that case, what happens is there's a method. I won't go into the technical detail of it, but there's a method by which you decide that, okay, this is the chain which is the right chain. So the chain which has got the maximum amount of work done, that is the chain which everyone chooses, and that is how a chain continues to happen despite having multiple blocks being contending for there. And once one chain is considered to be the right chain, rest of the blocks are called orphan blocks, and then they are removed. But in a case of contentious hard fork, what happens is there may be a second chain that happens, and people say that, okay, we'll follow the second chain now. So, and it's sometimes when there's a contention, it may happen that there are people get segregated. They say that somebody say that I will continue to follow the first chain, and the second set of people may say that we will follow the new chain. And that is what happened when Bitcoin gave rise to Bitcoin Cash as a different hard fork of Bitcoin. And same Ethereum Classic was a hard fork of Ethereum. So this sometimes have, but now I think as these were early times, but now as Ethereum, Bitcoin, some of the established protocols have become so big that there's hardly any hard forks being seen now. Now the hard fork may happen, which are more planned in nature. If there is some fundamental change to the blockchain, let's say, for example, Ethereum decides that, okay, we'll increase the size of the block. Then there is a democratic process. A proposal is given, and then a certain majority of people need to agree to it. Then a planned hard fork can happen. So hard fork will definitely happen whenever there's a major change happening in the core architecture of the blockchain itself. The second is SegWit. So SegWit is again a very technical way of doing it. So now, normally what happens when in the case of Bitcoin, if you see the normal blocks, so normal block has got transaction and there's a signature data. So signature data basically includes when a sender is verified. So whenever a new transaction happens in blockchain, we need to first verify the sender's identity. And second, whether it has got the right balance or not. And second is validate the transaction itself, that the transaction has not been tempered. So there's a concept of asymmetric cryptography through which this is ascertained. And this data becomes part of the transaction itself. So if you see a block, it has got the data related to the core transaction, like who is the sender, receiver, and the amount of token being transferred. But apart from that, there's a signature data. So that signature data typically takes about 70% of the block. So idea was that if we can segregate the signature data separately, then we can we get empty space and we can put in more transactions into it. So that is the concept of segregated witness, where you are segregating the signature related data from the block into a separate signature, and the block is filled only of transactions. So that's how SegWit helps putting in more transactions in the same size of block, and ultimately increasing in the throughput of the transactions. So more transactions can be packaged and committed into a block. Now coming to sharding. Sharding is something very interesting on-chain solution, which Ethereum 2.0 is also doing. And then there are a few blockchains like Sharding, one of our partners, using sharding to increase the throughput of a blockchain or bring in scalability. So what sharding done is that it basically breaks down the network into a smaller chains or smaller chains called shards. And these shards can, run transactions or execute transactions in parallel with each other. So that is how the transaction output would be increased, because now you are, handling transactions parallelly. So Ethereum 2.0 is coming up with sharding. So as part of different upgrades which are happening, last major upgrade was moving from proof of work to proof of stake. Similarly, as part of the further updates, sharding is one of the major upgrade which Ethereum 2.0 is doing. And in this case, there would be multiple shards, and each shard will handle a portion of the transactions. So that way, now rather than executing the transactions linearly, you would be able to handle the transactions in parallel, so that it will increase the transaction throughput. Shardium is also a new layer 1 blockchain, and what they are doing is very interesting, that whenever there is more transactions happening, so there's a sudden surge of users and transactions on the network, then to keep the gas fee at the same level, more nodes can be added. So that is what is called dynamic sharding, where you add more nodes to the network whenever there is a surge in the number of transactions and you want the gas fee to remain consistent. So Shardium is again a very interesting project which is using dynamic sharding. So these were the solutions. I just wanted to cover them very briefly. These were on-chain solutions. What can be done? So if you see Litecoin, when Litecoin came as a fork of Bitcoin, it increased the size of the block. So these were all different on-chain solutions, where sharding, I think, is a solution which is still being taken by Ethereum as well as some of the new protocols. But majority of new protocols, they fall into the layer 2 solutions. Now layer 2 is something like, there is a layer 1, and we know that layer 1 has got a limit as to the number of transactions they can process. But since we don't want to hamper the security and decentralization piece to it, is it possible that we execute the transactions outside the layer 1 and then submit a proof or bundle the transaction and submit it to the layer 1. So that way what we are doing is the execution part of it, the validation and execution of the transactions, if it can be done offline, and then the bundled proof that these transactions have been validated can be submitted on layer 1. So that is what a concept, and these are called layer 2 because they still depend on layer 1. They are not acting independently completely. So normally in most of the cases, generally if you see, what they do is the layer 2s take care of the transaction part. So they take the transactions, they verify, validate the transactions, and then bundle them together and submit the proof of those transactions to the layer 1. And the layer 1 provides them in turn security and decentralization. So it's like layer 1 and layer 2 are working together with each other, where layer 2 has taken bulk of the transaction load, and layer 1 is ensuring the security and decentralization to layer 2. So that is how most of the layer 2 solutions work. Some of the layer 2 prominent ones being state channels. Lightning Network is a very classic example of that. Plasma, which is not used much at this point of time, but the major layer 2 solutions are rollups, both optimistic rollups and ZK rollups. So we'll come to that. So first we'll briefly talk about state channels. So Lightning Network has been one very successful example, increasing the transaction throughput on Bitcoin. So in the case of channel, what happens is, again, it's offline. So a Bitcoin network is running as a main chain, and there are two parties who want to do transaction with each other. So they create a channel between them. And similarly, so channel is formed between two parties. So different channels are being formed, and transactions on those channels are happening off chain. And so they can be executed quickly, and the gas fee is also not a constraint. So you're not constrained by anything which is happening on the main chain. And once the payment transaction is through, it has been verified and validated, then the final record of the transaction is pushed onto the main chain, and the state is updated. So this is how, these are basically for payment transactions. So state channels are used only for networks like in Bitcoin, there's a Lightning Network, there's a Raiden Network on Ethereum. So they use state channels, but there are some limitations to state channels. One, it can happen only among two parties. So, and once the transaction is done, it is closed, and then all these closed transactions are then committed there. So there's a limitation as to what kind of transactions can be done. Of course, it do not support any kind of data transactions, the smart contract data transactions. It's only pure token transactions that can be handled by state channels. But as we know, Bitcoin do not have any native smart contract. It's not a smart contract platform. So their Lightning Network has become one of the most prominent network to increase the throughput of Bitcoin blockchain. Second are Plasma. So in case of Plasma, what happens is there are child chains, the concept of child chains. And those child chains again can have child chains. So it can be infinite number of child chains that can happen. And what happens is these child chains, are independent blockchains because they have their own consensus mechanism. But then these transactions happen on these child chains. And once the transactions have happened, then they are the Merkle proof of those transactions. They are submitted on the main chain. And since there can be n number of child chains, so of course it provides a lot of scalability to the Ethereum blockchain, and all the transaction verification validation is happening off chain, and the fraud proof of that is put on the main chain. So that is how the Plasma network works. But the problem is there's a long waiting period because, and I'll explain this further when we talk about optimistic rollups, that if the you are relying on a fraud proof, what it means is that you're doing a set of transactions off chain, and you're submitting the bulk of those transactions bundled together onto the main chain. But there may be possible that there's an invalid transaction that has been submitted by some bad actor in the network. So then somebody needs to ensure that all the transactions are valid. There's no so a fraud proof needs to be submitted, and so there are different trusted agencies who are given option to raise a dispute. So they can raise a dispute, and then based on the dispute, if an invalid transaction has been submitted, it will be rolled back. But the problem is that whenever this kind of dispute mechanism is there, then of course the transactions cannot be considered fully committed or finalized until unless the dispute time is over. For example, let's say the dispute time is given to be 7 days, that within 7 days anyone can raise a dispute. That means that any transaction, if you have done a token transaction on a child chain, and if you want to transfer that token onto the main chain, you won't be able to do that until unless that waiting period has been over. So this is one big limitation of using Plasma. But yes, at the same time, in terms of scalability, it definitely gives a huge rise in the scalability to the main chain. One of the example of Plasma is OMG. And third is the sidechains. So sidechains are very interesting. In fact, Polygon, one of the most popular protocol today, is based on the sidechain concept. So a sidechain is like an independent blockchain which is running in parallel to the main chain. And between these two, there is a, you can say, a middleware, which is like a bridge between the main chain and the sidechain. But they are completely independent chains in the sense that the sidechain will have its own blocks being written. It will have its own consensus. It may have its own validators also. So everything is independent. But then there is a two-way pegging that happens. So there's a bridge in between them, which runs like a two-way peg. And this ensures the transfer of asset from one chain to another. So for example, let's say you are operating on Polygon and you have Ethereum asset on Polygon. Or let's say take the other way around. So let's say you have Ethereum tokens on the Ethereum main chain and you want to bring those tokens on the Polygon chain. So then there is a bridge in between. So what it does is, and that bridge is controlled by a trusted third party. So what you will be doing is, you will be first, let's say you want to transfer one Ethereum from Ethereum main chain to the Polygon chain. So what you need to do is you need to lock, because there's no actual transfer that happens through the bridge. The way it works is, you lock one Ethereum, your one Ethereum will be logged on the main chain. You cannot use it anymore. And then once the trusted third party can ensure that yes, this lock has happened, then on the Polygon chain, Ethereum will be assigned to your wallet. So one Ethereum will be generated here when there's a lock there. And the reverse process happens whenever you want to get your Ethereum back on the main chain. The Ethereum that you have on the side chain will be locked and the main chain will be opened. So this is how the communication happens. But and there are quite a few chains, like xDai is again very popular chain, and Polygon has been very chain on Ethereum. And in case of Bitcoin, Rootstock, and the purpose of Rootstock was not just to bring in scalability, but also Rootstock come up with the smart contract capability to Bitcoin. So Bitcoin being a pure and pure token platform, there's no smart contract capability, there's no virtual machine there. So Rootstock is bringing scalability also, at the same time bringing smart contract capability to Bitcoin network. So this is how sidechains work. There are various limitations, because if you see, sidechain does not inherit security from the main chain. So they need to manage their own security to a large extent. So that of course bring in challenges to the security. Second, there's a risk of centralization, because there's a trusted third party, again limited by numbers. So there's a chance that there is centralization there. And then since there's a bridge which is locking tokens on one chain, unlocking on another, and vice versa. So these bridge may have some security challenges, and we have seen cross-chain bridges, etc., have been hacked quite a bit in the last few years. So that again is a challenge to a sidechain. But sidechains have been very successful, especially Polygon, xDai, and Rootstock have been very, very successful layer 2 solutions to bring in huge scalability to the Ethereum and Bitcoin ecosystem. Now we'll talk about the rollups, which are the most popular layer 2 solutions today. And there are two kinds of rollups. In fact, if you see from a market size perspective, rollups overall constitute almost 95% of the Ethereum layer 2 market. So they are quite popular. And how the rollup work is that, again, you do a transaction off-chain separately. You take all the transactions and you roll up those transactions, you bundle them together, and the batch is rolled up. As a roll up, it is moved onto the main chain, submitted on the main chain. So this is how typically it works. And that's why they are called rollups. So it's very similar to like a zip file work where, you can combine multiple files. And I was seeing a video where, let's say, you want to send a letter to your family who is living in some other city. And let's say there are 5 members in the family. And if you want to send greeting cards or letters to each of them, it would not make any sense to write 5 different letters and put them into 5 different envelopes and courier them separately, right? Rather than that, you can bundle all the 5 cards into one large envelope. So it's pretty much similar to that, where you are bundling the transactions together and one batch of transaction is then submitted on the main chain. And technically, how this happens? So in the case of Ethereum, there are 2 kind of pieces. So one is the token transactions, what we call simple transactions, transferring one token from one person to another. These are token transactions. So traditionally, from Bitcoin to Ethereum, that is how the transactions came around. And what has transaction? It has got a sender, it has got a receiver, it has got the transaction message, which pretty much includes the quantity of token being transferred. And then apart from some signature pieces, etc. But then when Ethereum came up with this concept of smart contracts, it came up with Ethereum virtual machine, which gives the capability of smart contracts. So now you can write any kind of data on the blockchain. So it may be healthcare data. In the case of decentralized identity, it may be your personal data. So depending on what kind of smart contract we are talking about, it can be any kind of arbitrary data that can be now written into the block. So there's a way to bundle in transaction, and then there is a way to bundle in the data using smart contracts. What rollups do is rollups use this data functionality. So they take a transaction and put them into a rollup contract. So and that is how they put the large number of transactions into the main chain, and that's how you increase the number of transactions that can be processed overall. So now there are 2 types of rollups today which are very popular. One is the optimistic rollup, and the second is ZK rollups. So what are optimistic rollups? So optimistic by the word means they are very optimistic. It means you bundle in all the transactions and you submit the transactions to the main chain. And you do not need to provide any valid proof that each and every transaction has been verified and validated. And you are assuming, you are optimistic that yes, the transactions would be fine. And then there is a concept of, again, a dispute kind of concept is there, where a 7-day window is given, and anyone can submit a fraud proof saying that some of the transactions in this block of transactions are invalid. So so this is how optimistic rollup works. And what happens is normally no fraud proofs are submitted, because most of the transactions are most of the time the transactions will be correct. The reason is because of the incentive-disincentive mechanisms. So if, let's say, somebody submitted invalid transaction into a set of transactions in a rollup, and through the fraud proof, through the dispute mechanism, somebody submitted a fraud proof. So there's a concept of slashing. So when you wrote the, you submitted the transactions, invalid transactions, you are staking certain tokens to participate in that exercise. So your tokens would be slashed. So you will be penalized. That's called slashing. So this penalize, disincentivize the submitter of transaction to ensure that there are no invalid transactions. Similarly, if, let's say, you have submitted valid transactions, but then somebody unnecessarily raised a fraud proof. So at the time of raising a fraud proof by somebody who is disputing they also need to put in certain tokens, and those tokens will be slashed if the fraud proof is considered to be wrong itself, if you're raising a false alarm. So optimistic rollups are pretty much like, innocent until proven guilty. So all the transactions are considered to be fine, and there's a 7-day window which is given to raise the disputes. Transactions in optimistic rollups are very fast, but then, again, the kind of challenge we saw earlier. In this case, if you want to withdraw your funds and move them to L1, to the layer 1, then you need to wait for 7 days before the fraud-proof publishing window ends. Then, the transactions will be considered 100% final. So that's a limitation of it, but optimistic rollups are very popular. In fact, Arbitrum and Optimism are two kind of optimistic rollups today. What is the difference between Optimism? How the optimistic rollups have been improved in the case of Arbitrum or Metis or POA Network? I'll cover that in the separate webinar when we'll talk about rollups. But Arbitrum today has got the maximum TVL, total volume locked, of liquidity across all the DeFi ecosystem. So we have seen that Optimism and Arbitrum has got huge traction in the market, and they are quite big players right now. Metis and POA being comparatively new players. POA is a new network. But yes, overall, optimistic rollups have been very successful, being a layer to an increasing scalability. The second are zero-knowledge snark rollups, in short called zero-knowledge rollups. Now, what is zero-knowledge? So the concept of zero-knowledge is that you want someone to verify a certain set of transactions that you have without disclosing the transactions that you have. So you're not giving any knowledge of the transaction, but still you are able to prove to the verifier that you have the right set of transactions and they are valid. So that is what a concept of zero knowledge. It's a mathematical concept extended to quite a few other pieces. In the case of blockchain, zero knowledge is used for privacy, because you do not want to disclose the data, yet the verifier would be able to verify that yes, you have the right set of data. In the case of rollups, there are ZK rollups. It's again a different kind of rollup, but the essence remains the same. One major difference in the case of zero knowledge rollup is that in this case, you do all the proof before submitting the transaction. So you're not optimistic here in the case of zero knowledge. So there is a cryptographic proof of every transaction within a batch. And then once that, along with that proof called validity proof. So the set of transactions along with the validity proof that is submitted on the main chain. So there's no dispute kind of mechanism here, which is not required. So that's why ZK rollups are very, very fast, much faster than that. But one of the downside of GK rollups is that they do not have smart contracts. Like in the case of optimistic rollup, they have virtual machine also and smart contract capability. But typically ZK rollups do not have that. They can just process transactions. There's no smart contracts, so no alternative or arbitrary data that you can use on them. But yes, there is no waiting period or no dispute period, so asset withdrawals can happen almost instantly. That was not the case with optimistic rollups. So ZK rollups, again, we have ZK Sync as one of the leading players. And then there were a player called Hermes, which Polygon acquired, called Polygon Hermes, and Polygon Zero Few. Loopring is again a pretty decent sized player along with ZK Sync on the ZK rollups. And now there are quite a few other ZK rollups coming in. In fact, there's a ZK rollups, in fact, has become one of the biggest buzzword in last 6 months to 1 year. But then there's something else, like, you must have heard of ZK AVM, which Polygon recently launched. And Zeeve is one of the few players in the world to give support of ZK AVMs. So ZK AVM is very interesting. They have taken ZK rollups, but added EVM to it, so that now you have smart contracts also, and at the same time you have all the capabilities of zero knowledge rollups. So very interesting project. And similarly, a lot of other interesting innovations are happening in the zero knowledge space. In fact, a lot of funds are being allocated. A lot of grants have been released by most of the popular protocols, whether it be Algorand, or Solana or Avalanche. People are spending a lot of money to invest further into zero knowledge proofs and zero knowledge rollups. Lastly, so I hope you have got the gist or a high level overview of different kind of solutions that we talked about. Lastly, I'll have on this slide on app chains. So app chains behave very much like a sidechain. So the idea is that there are quite a few use cases who want to have independence in terms of setting their own token economics. So today what happens is, let's say you are building a DeFi startup or you are building an enterprise solution, right? Now, if you're building a DeFi startup, you may build token contracts, you can design token economics, you can deploy everything on the main chain as ERC20 token, etc. But let's say you require a lot of independence, that you want your consensus to behave in a certain way. You want your token economics to be designed in your own custom way, right? You want your transaction throughput to be in a certain way, your gas fee to be in a certain way. So if you want all these, you require your own blockchain. But launching your own blockchain is a very onerous task, because it's not just about creating a technology base. You require blockchain, you require all the alternative or associated components, whether it be Explorer, wallet, and so on and so forth. But in addition to that, one of the biggest challenges, you need to have sufficient number of validators, third parties who are going to host nodes and run your blockchain network. Because unless you do that, then it becomes more of a centralized blockchain, which does not make any sense. So to achieve a decentralized network, creating your own blockchain, it's a huge project. And so, but not everyone can do that. Especially, it's very difficult for startups to even think of doing such a large project. So for that, the concept of app chains came in. So app chains are like, you have the main chain, but you have a subnet or a sidechain kind of chain, where it's a completely independent chain in the terms of you can configure it whichever way you want. You can plug in your own consensus also. You can have your own set of token economics, etc. And at the same time, you're connected to the main chain. You're taking the security and validators from the main chain. So the major problem when you're launching your own blockchain is to bring in validators. So just imagine you're launching your own blockchain, but you're getting it validated by the main chain validators. So when on the day of your launch, you will have many validators who are already part of the main chain would be validating on it. So that is the concept of app chain. Rather than creating your own independent blockchain, you are creating a side chain to a main chain, and that is called app chain. So one, from a technical standpoint, you have a lot of flexibility. You are not burdened by, so whatever may be happening in terms of gas price or congestion on the main chain, you're not burdened by that, because you have your own transaction throughput, your own gas price, etc. But at the same time, you solve the challenge of sufficient security and decentralization by taking or leasing that from the main chain. Why they are called app chains? Because they are application specific chains. So if you are a DeFi customer, you want to create your own blockchain based on your application, which is very much customized to your application. Your application may require some custom parameters, some compliances, some configurations. So you can have an independence of doing that, yet at the same time, you're connected to the main chain. So application, and now more and more players are getting into it. Polygon launched the concept of Polygon Supernets, which basically again is a concept of app chain. You can create your own supernet. You will be validated by Polygon validators, but you can have your own independent configuration while designing a supernet. A lot of enterprises are looking at app chains because, as I mentioned, in a case of DeFi, you can have your own configurations. But if you're an enterprise, you can have a flavor of both permissioning and public blockchains. So you have validators coming from the public blockchain, so they are verifying. So you are ensured that thousands of users across the world who are unknown to each other are validating the transactions. But at the same time, who all can participate into submitting transactions, etc. You can have flavor of permissioning also. So a lot of enterprises are now looking at app chains as compared to traditional enterprise protocols. So Polygon Supernet, and then we have Avalanche Subnet, which again is one of the leading players right now in the market, which has got huge number of players who are building subnets today. And again, the concept is very similar. You can create your own subnet. You have huge independence while creating a subnet. And the mainnet validators, the Avalanche C-chain validators will be validating on your subnet. And then substrate parachains. I think Polkadot has been the leader in this space. Polkadot from day one has been launched as the network of networks, where these parachains are the chains which has got the smart contract capability, and people do all the transactions in parachains, and those transactions are then relayed across to the main chain. And then there are a few others. So these are three leading players right now: Polygon Supernet, Avalon Subnets, and Substrate Parachains. But apart from that, Binance has also now launched this. Near Protocol has in fact launched the concept of private shards, again very similar to app chains. And then Cosmos again has been, along with Polkadot, has been leader in this space, has got the concept of using Cosmos SDK. You can create your own app chain. Now, one other point which is very interesting is, as I mentioned, security and decentralization you are leasing out. The other interesting point is that all these app chains, like all subnets of Avalanche, they are interoperable with each other. So they have interoperability built into it. So you do not need to resort to some weak cross-chain bridges, but you can use some native messaging protocols to have interoperability among all the subnets and with the mainnet. So that again becomes very interesting. As these ecosystems will grow, there will be native interoperability among the subnets and side chains and along with the main chains. And as we know that interoperability is something which people have already started facing the heat. It has been the hot topic for so many years. And a lot of pieces have been done. In fact, I'll cover a separate webinar talking about different options for interoperability. Because as we are seeing more and more protocols coming in, more and more apps being built on different platforms, and it is very clear that we are not going to see any consolidation happening in the market. There would be a number of blockchain protocols that are going to exist. So interoperability becomes must, because otherwise what happens is we are seeing this in the case of liquidity. The liquidity is spreading across different platforms like Arbitrum, Optimism, Polygon, Ethereum, Solana. It divides the liquidity. Just imagine a scenario, and there are quite a few startups who are bringing cross-chain liquidity, because until unless there's a strong liquidity, the trading markets, etc., markets will start suffering. So interoperability again is a very strong piece of designing app chains. So app chain is a very interesting concept, and of course brings a lot of scalability also to the main chain. So this is pretty much I wanted to cover. Just to summarize, we saw some solutions which have been done on the layer one itself, like SegWit or doing a hard fork, and then Lightning Network specifically we talked about. And then we talked about layer 2 solutions. And layer 2 solutions, we talked rollups has got the maximum market share. Most of the TVL today is within the rollups. But apart from rollups, there's a concept of sidechain, there's a concept of plasma. And then we briefly talked about app chains, application-specific blockchains. So if there are any questions that I can answer, do let me know. I think we have got a few minutes. And in any way, so meanwhile, anyone putting in questions. So Zeeve is a Web3 infrastructure as a service platform. We provide Web3 APIs, node infrastructure. So if you are building on blockchain, whether as an enterprise or you are building as a blockchain Web3 startup, you can use Zeeve platform to build faster, go to market faster. We provide all the necessary infrastructure tools for you to build your dApps or decentralized applications. Today, we have more than 25,500 developers and Web3 startups using our platform, and 30 plus large enterprises who are using our platform. We support 40 plus blockchain protocols. So pretty much all the different EVM and non-EVM protocols that I mentioned today, whether it be Optimism, Arbitrum, Polygon, Avalanche, Polygon Supernets, Avalon Subnet, Substrate Parachains, we support all of these protocols and quite a few new ones like Sharding, etc. So, and do follow us we continue to do a lot of webinars, Twitter spaces. We cover a lot of technical topics, try to make it very simple to understand. We also help if you are a startup and if you have any questions, any doubts, how to get started, you can attend our meetups. We do meetup every week across different cities in India, different hackathons. To join us channels, join us on Telegram, Discord, LinkedIn or Twitter, and stay updated with all the events and infrastructure pieces that we're doing. So one question, what are your thoughts on sharding for scalability? Yeah, so sharding, I covered a separate slide on sharding today. So sharding is definitely a very interesting concept. In fact, as I mentioned, Ethereum as part of its various major upgrades on the Ethereum 2.0, sharding is one of the upgrade. And Shardium itself is a sharding blockchain from day one. And they use dynamic sharding, where the gas price will always be low. Even if the number of transactions increase, you can add more nodes, more shards to take care of the increased number of transactions. So it's comparatively very scalable. And Shardium has been promoted by two very exciting Nishchal and Omar. Very innovative early starters in this space. So again, a very interesting project. We are the preferred infrastructure provider for Shardium, a very strong partnership we have with Shardium. We support the validator nodes as well as full nodes. Right now, Shardium is in testnet stage, and they are going to launch their mainnet sometime in Q3. We are expecting August or September. So stay tuned. It's an exciting project. So if there are no further questions, Joe, thank you for attending the webinar today, and do attend the next two webinars where we'll talk about app chains and different kind of app chains, how they are architected, different use cases being built on them. Similarly, one webinar on rollups, optimistic and ZK rollups, again from an innovative standpoint, to understand what are the hot topics, hot innovations happening in the blockchain space. Do follow us and attend those webinars. Thank you. Thanks for your time.